Harriet, 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 Harriet. Give you.
Andrew, what is it?
Am I the one with the problem?
It's
I
not
was
only.
saying that.
It's the same.
I was saying that. If I take an example for beta, to be a scalar. So the scalar multiplication beta will multiply throughout U in that form. Then here is a quick example which one can try out if U is that and V is that. Now these are vectors. You see they are made up of three coordinates, 3 points each. So it is in R3. So one can compute U plus V, and also if alpha is 2, I want to believe that alpha V can as well be computed using what I have explained. Then there is also the dot product of vectors. Dot product. So how is it defined? Still, I'm going to consider vectors V and U in Rn. The examples which I have listed above, I don't want to repeat them. Then the dot product of U dot V, this will be L1, L2, up to AN dot B1, B2, up to Bn. So we multiply as we add. We multiply correspondingly as we add. So this will be L1 times B1 like that, then plus L2 times B2 up to AN times Bn. That is the dot product of two vectors. Still, I take a quick example. By the way, it is important to note that if the dot product is 0, then we say that U and V are orthogonal. Orthogonal vectors.
Ebintu bihangire niyo network ekurugarugaho yakarugaho mirundi 10 nkugenda ine nsanga handikire ebintu
all hari all.
So if we go off, kindly use the same link to join. An example. if u is 1, -2, 3, and v is 4, 5, -1, and w is 2, 7, 4. So what is the dot product of u? What is u dot v, u dot w, and the v dot w? I want to believe that this is very easy to deal with. For example, let me do one. For example, u dot v, this will be 1, -2, 3, dot 4, 5, -1, and this is equal to 1 times 4 plus -2 times 5 plus 3 times -1. And this is 4 minus 10 minus 3, -9. So similarly, one can also do the same for u dot v, for u dot w and v dot w, like that. Then which other technicality should I comment on? There's what we call norm of a vector. Norm of a vector. Norm of a vector. So what is it? Still, I'm going to take my example above. Of u, and say that the norm of u in Rn, recall that u was in Rn, the norm of u in Rn is defined as this is equal to the square root of the dot product of u dot u, and is equal to the square root of a1 squared plus a2 squared up to an squared. From my definition above for u, that is how we define norm of u. Then, if the norm if the norm is 1, the norm is 1, then we say that u is a unity vector. The unity vector, like that. So a quick example as well. Quick example. Example.
Hiyo joto ya gipo.
Take U to be 1, -2, -4, 5, and 3. That.
This meeting is being recorded.
Then then we have the following. So I want to compute the norm if U is that. The norm of U is the square root of U dot U. So one has to first establish U dot U. But U dot U is 1, -2, -4, 5, 3, dot 1, -2, -4, 5, 3. And if you dot that, this is 1 times 1 plus -2 times -2 plus -4 times -4 plus 5 times 5 plus 3 times 3. And this is equal to 55. Therefore, substituting 55 back, the norm of U will be square root of 55. Yeah, square root of 55. So this session is ending, I think, in 1 minute from now. So you can use the same link to join into another session.
Excuse me.
You excused?
I'm wondering, a vector having all those dimensions, I thought it ends with 3.
That's why initially I defined Rn. You cannot put a restriction on the dimension. You can have n equals 1, you can have n equals 2, you can have n equals 3, you can have n equals 4. So it goes beyond n equals 3.
Okay.